Hello everyone, this is Poorani. We are going through chapter 9 of class 10 NCERT textbook. We have seen reflection in the previous videos. From this video, we will see refraction of light. So, we all know that the speed of sound changes from medium to medium. What does this mean? Sound travels with a particular speed in a particular medium. So, meaning sound travels with a speed in air, it travels with some other speed in solids. Say, this we have seen with examples in the previous classes. Say, if we place our ears on the railway track, we will be able to hear the sound of train coming even before we could hear it in air. So, which means sound is traveling faster in solid than in air. So, a similar thing happens with light also. So, light travels with different speeds in different media. So, this change of speed of light from one medium to another causes refraction of light. Previously we saw reflection of light, which means as the light hits the surface of a mirror, the light was bouncing back to the same medium. Say if it travels from air, it meets the surface of a mirror, it comes back into the same medium. This is reflection. Now what happens in refraction is, we have a transparent medium. Say we have a glass, which means light can pass through that medium. So when it enters this medium, it is going to change its speed, meaning it is not going to travel in the same line as it has traveled from in air. So there is going to be a change in the direction of the light ray. So this is what we mean by refraction. So this phenomena we have seen it in everyday life. We will see few examples of this refraction of light in our everyday life. As you see this picture here, in which we have the pencil inserted in a tumbler half filled with water. So what do we see here is the part of pencil which is immersed in water seems to be away, or it is not in straight line as it is in air. So which means that there is a bending of light when it travels from water to reach our eyes. So there is this bending of light. So this bending of light when it travels from one medium to another is called refraction of light. One more example which we very often see is mirage. So what is a mirage? When you travel in a hot place, say if the temperature is very high, we are traveling in a car, say, we will be able to see patch of water which at a distance. So what is this patch of water which appears? There is no patch of water, as we all know. There is no water there. It is just it is just road. But still we see a patch of water to be appearing when we travel in a car or anything. So what is this patch of water which seems to be there on the road? This is the reflection of a nearby tree. So that is what we have in this picture. See, there is this tree. The air here is hot. So the cooler air. What happens is the light which is traveling between two hot air and cool air is forming the image of this tree on the road. So this is again a phenomena of refraction of light which causes this mirage. So this is what we have for refraction of light. So now we will see refraction of light through a rectangular glass slab. So this is a very important experiment which we should be doing in this year. In this experiment, what do we do is, it's a very simple experiment and a very easy way to understand refraction. So what do we do is, we place a glass slab. As we see here, there is a glass slab. Say the glass slab is named A, B, C and D. Yes. So this glass slab is here and we place two pins, say at the point E and F. Two both pins is placed at the point E and F, and we look at this pin through this CD, and we place two more pins at the exact position where we are able to see the image of the pins at E and F. So this we place and we draw lines. Okay, so we first trace the rectangular glass slab A, B, C, D. So we see that this E, F, where the pins are placed, we take out the pins and we draw the lines, and we extend it to the side AB of the rectangular glass slab. Then we see that the light emerging from here, where we have placed the other two pins at the place of the images. So G and H, we draw this line again. So this is the picture of the rectangular glass slab we get. And what we do is, we draw normal at the point O where the light is incident on the side AB, and we draw another normal M dash at the point O dash where the light is leaving the glass slab from the side CD. So when we draw all these, what do we get is, this angle here will give us the angle of incidence. Yes, and this is the angle of refraction. So it is getting refracted. There is a slight bend, and as it emerges out, the ray is again bending away from the normal. So what do we infer from this diagram is, first thing we have to know is, air is a rarer medium. From a rarer medium, it moves to a denser medium, which is glass slab. When it moves from air to glass slab, what happens is, the light ray bends towards the normal. Yes, the light ray is bending towards the normal. Now again at this point O dash, when the light ray is emerging out of the glass slab, it is traveling from a denser medium to a rarer medium, which is again glass slab to air. So when it travels from a denser medium to a rarer medium, we see that the emergent ray here is emerging, it is bending away from the normal. So this we have to know, away from the normal. So as you see, these two rays EF and GH, they are parallel to each other. Yes, so this bending at the point O towards the normal and at the point O dash away from the normal are equal but opposite. So this is bending towards the normal and this is away from the normal. So now what happens is, the ray becomes straight, parallel to each other. The EF ray and the GH ray are parallel to each other. Yes, so this is what we have for refraction through a rectangular glass slab. So from this experiment, what are we going to learn, what are we going to find out is there are this bending of light follows certain laws. As we saw previously for reflection of light, we have laws for refraction of light also. So this again is very important to know. From this we are going to develop the sums. Yes, so a very important point to be noted in this refraction of light is these two laws. Yes, so the first law is very similar to the first law of reflection. This says the incident ray, refracted ray. There we saw reflected ray, now it is the refracted ray, and normal to the interface at the point of incidence lie in the same plane. So this is the same thing as the first law of reflection. Now when we go to the second law, this we have to understand very clearly. What does this state? The ratio of the sine of angle of incidence I and the sine of angle of refraction is a constant for the light of a given color and for a given pair of media. Say if we consider air and glass, there will be the constant, there is one constant. If we consider glass and water, the constant will be different, meaning the ratio of sine of angle of incidence and the sine of angle of refraction will be different. So this we have to understand. So the second law is called as Snell's law. So that is what we have a diagram here explaining Snell's law. So this is the incident ray. Yes, the incident ray, and this is the angle of incidence I, and this is the angle of refraction R. As we see, the ray is bending towards the normal, meaning the light is traveling from air to glass. So medium 1 is air, medium 2 is glass. So this sine of angle of incidence by sine of angle of refraction is equal to constant. This constant, yes, this constant is called as refractive index of the medium. Refractive index of, to be very specific, we call it refractive index of medium 2 with respect to medium 1. Here the medium 2 is glass slab or glass with respect to air. Okay, so this is what we have for laws of refraction. So this we will see in detail. So this refractive index which we just saw from the Snell's law which we get, we will go through in detail about this refractive index. So again the same diagram we have, the incident ray is bending towards the normal. This is the angle of refraction, angle of incidence. So here what do we have here? We denote the refractive index as N21. What do we mean by 21? We mean that it is the refractive index of the medium 2. Here glass with respect to medium 1. So the speed of light in medium 1 by speed of light in medium 2. This is a constant. That's what we saw in the Snell's law. So this V1, which is the speed of light in medium 1 divided by speed of light in medium 2, V2. Similarly, we can write N12, which is speed of light in medium 2 divided by speed of light in medium 1. Yes, so this is the refractive index of air with respect to glass. Oh, so these two things are similar things, but the we have interchanged the medium. So we have taken first one, we have given the refractive index of glass with respect to air. Second one, when it is N12, it is refractive index of air with respect to glass. So from this, what do we infer is one will be the reciprocal of the other. Yes. So now in general, when we talk about refractive index, we talk about the absolute refractive index of the medium, which is with respect to air or vacuum. The speed of light is maximum in vacuum. What is the speed of light? We have it as 3 into 10 power 8 meter per second. This is the speed of light in vacuum, which is the highest. The speed of light will only reduce when it goes to the other medium. Okay. So in air, it is more or less equal to vacuum. There is no much difference in the speed of light when considered to speed of light in vacuum. Okay. So now we are talking about absolute refractive index of the media, say glass, water, or whatever media we are considering with respect to vacuum or air. So that will be our absolute refractive index, which is denoted as Nm here. Nm is the refractive index of the medium, absolute refractive index of the medium, with this which is with respect to air. So the speed of light in air, which is denoted as C, which is equal to 3 into 10 power 8 meter per second. This C here is equal to 3 into 10 power 8 meters per second. Yes. So then the divided by the speed of light in the medium. Say when we say medium, it can be glass, it can be water, or whichever medium we are talking about. So this will be the absolute refractive index of the medium, or simply we call it as refractive index. So we have a table denoting the refractive index of various media. Say for air, the refractive index is 1.0003, because in vacuum the speed of light is slightly higher than in air. So there is a small variation or small this thing, it is not equal to 1. So there is a refractive index of 1.0003 for air. So then we have it for ice, which is 1.31, and water 1.33. So these are the refractive indices of various media. So when we see here, it is for benzene it is 1.5, crown glass 1.52, all this. So this we will use it in the sums which we will be doing later. Yes. So with this we finish this video, and in the next video we will see few problems from this. These are very important concepts with regard to refraction of light. So we will concentrate more on these concepts when we do the sums later. For doubts and clarifications, please feel free to message me on the WhatsApp number given in the description box, or mail me in the mail ID given in the description box. Thanks for watching. Happy learning.